Hello everybody and welcome back. In this lecture series, we are going to create, train and evaluate the cardiac detection model. At the end of this unit, you will have a network capable of accurately predicting the position of the heart in X-ray images. Before starting, let's briefly discuss the necessary libraries. We use Torch and Torch Vision for model and data loader creation, PyTorch Lightning to handle the training, the model checkpoint callback and the TensorBoard logger for checkpoint saving and logging, NumPy for data loading, CV2 for visualization purposes, the Augmentress library from EMG.org for our augmentation pipeline, and last but not least, our cardiac dataset. At first, we should define the paths to the X-ray images and corresponding patient IDs. Let's create a variable called train_route_path, which takes the path to the train images. In my case, this is simply processed heart detection/train. The train subjects are also stored in this directory as train subjects.npy. Additionally, we define the validation route path, which is simply processed heart detection/val. Last but not least, we define the path to the validation subjects. They are stored in the same directory in the file val_subjects.npy. Now we can define our augmentation pipeline and store it in a variable called train_transforms. It takes the EMG.org sequential object to which we pass the same augmentation functions we already used when evaluating our dataset. This included random contrast changes and random affine operations. In fact, we use random scalings from 0.8 to 1.2, random rotations from -10 to 10 degrees, and random translations from -10 to 10 pixels. Alright, let's define our datasets. We start with the train dataset, which takes our cardiac dataset object, to which we pass at first the path to the label CSV file, which is in my case simply the file name as I'm working in the same directory. Next, our train subjects, the train route path, and last but not least, our training augmentation pipeline. To define the validation dataset, we can simply copy this line from above, replace train subject and train route path by validation subjects and validation route path respectively, and replace our augmentation pipeline by none as we don't want to apply test time augmentation. Last but not least, we define batch size plus num workers and finally create our train and validation data loader. For the task of cardiac detection, I will use a batch size of 8 and 4 num workers. Let's create the train loader by calling torch.utils.data.dataLoader, to which we pass our train dataset, the batch size, the num workers, and set shuffle to true. Again, when defining our validation loader, we simply copy the line from above, replace train dataset by val dataset and set shuffle to false. Cool! Our data loading routine is complete. In the next lecture, we will create the cardiac detection model. Thanks!